Assalamu alaikum wa rahmatullah. In this video, we will talk inshallah about trigonometry. Trigonometry is a new branch. You will study it in this year, okay, in mathematics, okay. It's a very complicated word, I know, but it's consists of two parts. First part, trigonon, it's about triangles, okay, metry, measurements, okay, then it's measurements of triangles, okay, and we use it to find the ratio between sides and the angles of triangles, okay, sides and the angle of right angle triangle. First, let's know some basics. I will remember some basics about right angled triangle, okay. Right angle triangle is a triangle which has a right angle, okay, here, right angle, and the other two acute angle. First, we must know that the side opposite to right angle is called hypotenuse. This side is called hypotenuse. Okay, and we also can say that the sum of interior angle of any triangle equal 180, and in this triangle the sum of two acute angle equal 90 degrees. Sum of two acute angles equal 90 degrees. Right angle with 90 degrees and other two acute angles with 90 degrees. Also, we can use Pythagoras theorem, that if we have here A, B and C, it's right angle triangle at B, then we can say that hypotenuse power 2 AC power 2 equals AB power 2 plus BC power 2. And also we can say that AB power 2, if we need to find the AB, it will be equal hypotenuse AC power 2 minus BC power 2. And if we need to find the BC power 2, it's gonna be AC power 2 minus AB power 2. Let's see an example. Okay, here in this triangle, it's right angle triangle, okay, with 90 degree here. Okay, if we have this side is 3 centimeter and this side is 4. What about the third side? Okay, third side here is the hypotenuse. I can't find the hypotenuse. Okay, mention it with h power 2 equal 3 power 2 plus 4 power 2, then h power 2 equal 9 plus 16. 9 plus 16 equal 25, then h equal root 25 is 5. Root 25 is 5 centimeter. Okay, after that we have three main trigonometrical ratios. First one we call it sine. Okay, second one is called cosine, and third one is tan. Okay, we can easily remember them using ka and toa. Okay, let's see. Trigonometrical ratios is used to find the ratios between sides for the acute angles in right angle triangle. This angle and also this one. Okay, mention this angle with let's say x, for example. Okay, this angle is x, this angle. Okay, then the side opposite to this angle is called opposite. Okay, and the side is next to this angle, this side is called adjacent. Okay, and the side opposite to right angle is called hypotenuse. Okay, let's find sine, cosine, and tan for angle x. First, sine x. Sine x equals what? Sine equal, so it's opposite over hypotenuse. SOH, so it's opposite over hypotenuse. Sine equal opposite over hypotenuse. Okay, for x, opposite for x is this side, 3. So it's a 3 up here, over hypotenuse. Hypotenuse is 5, so it's a 3 over 5. Okay, what about cosine? Cosine equal. Cosine, it's adjacent over hypotenuse. It's adjacent over hypotenuse. Here, for x, the adjacent for x is 4, and the hypotenuse here for this triangle is 5. So it's 4 over 5. Okay, let's see what about tan or tangent. Okay, tan x equal. Okay, so here it's cosine x. Okay, tan x equal. Tan is opposite over adjacent. Opposite from sine over adjacent from cosine. So it's tan is opposite over adjacent. Where is opposite? Opposite here for x it's 3, and over adjacent it's 4. So it's 3 over 4. Okay. If we draw other triangle here, same one, with 3 here and 4 and 5, but we will find the main trigonometrical ratios for not this angle, no, for this one. We will call it angle y. Then 3, this side is not opposite anymore, it's the adjacent now for angle y, and this side is not adjacent, it's opposite now for y, and 5 is still hypotenuse. Okay, hypotenuse doesn't change. Okay, then let's see if we need to find sine y. Sine y in this triangle, sine is opposite, we say, so it's opposite over hypotenuse. Opposite for y is 4, so it's 4 over hypotenuse for y is 5. After that, okay, after that, cosine y equal. Cosine for y, it's adjacent. Cosine is adjacent over hypotenuse. Adjacent here is 3 over hypotenuse 5. So it's 3 over 5. 3 over 5. Okay, let's see. What about tan? Tan y. Tan y, it's opposite over adjacent. Opposite over adjacent. So opposite for y is 4 over adjacent 3. 4 over 3. So it's 4 over 3. Okay. In the previous, we can say that or notice that sine x equal cosine y. Okay, sine x equal cosine y, and also sine y equal cosine x. Sine y equal cosine x. Remember, what is the relation between x and y? X and y. What is the relation between x and y? Yes, their sum equal 90 degrees. They are complementary angle. Then we can say if measure angle A plus measure angle B for any two angles A and B, X and Y, Z and F, whatever. if measure angle A plus measure angle B equal 90 degrees. Like here, measure angle X plus measure angle Y equal 90 degrees. Then we can say sine angle A equal cosine angle B, and vice versa. We can also say cosine angle A equal sine angle B. So if we have two complementary angles, complementary angles means their sum equal 90 degrees. Then we can say sine first angle equal cosine the second angle, and cosine first angle equals sine the second angle. Okay. What else? What if we divide sine x divided by cosine x? Let's see. If I need to divide sine x over cosine x, it's gonna be here. Sine x is 3 over 5 over cosine x is 4 over 5. Okay, let's erase 5 with 5. I get what? I get it's 3 over 4. 3 over 4 equals what? Equals tan x. So we can say for any angle, tan any angle like A equals sine this angle A over cosine the same angle A. So we can say that for any angle, tan this angle equals sine over cosine the same angle. Let's see an exercise. If sine A equal cosine A, find measure of angle A. We can simply say that sine A equal cosine A, then measure angle A plus measure angle A must be complementary. Then I can say that measure angle A plus measure angle A equal 90 degrees. These two angles must be equal 90 degrees. Then 2 measure angle A equal 90 degrees. Then measure angle A, one of them must be equal, divided by 2, then it will be 45 degrees. Okay, another one. If sine A equal cosine 2A, find also measure of angle A. Okay, here we can say that measure of angle A plus 2 measure of angle A equal 90. 3 measure of angle A the same, equal 90, divided by 3, measure of angle A gonna be 30 degrees. Okay. Another example. In the opposite figure, we have here triangle A, B, C with right angle triangle at B. We have BC equals 6, AB equals 8, and he asked me to find number 1 sine sine angle A times cosine angle B. Number 2, sine power 2a plus cosine power 2a. Let's see solution. First, here we have that AC equal from Pythagoras 8 power 2 plus 6 power 2 gonna be 64 plus 36 gonna be 100. So AC equal 10 centimeter. So here AC is 10 centimeter. After that, let's calculate the main trigonometrical ratios for first for angle A and angle C and angle C. Sorry, here it's C. Okay, sine A equal opposite of A is 6. Hypotenuse for A is AC, so it is 6 over 10. 6 over 10. What about cosine A? It's gonna be adjacent of A, cosine K, so it's adjacent over hypotenuse, 8 over 10. So it's 8 over 10. Okay, we need sine A, cosine A, and cosine C. Let's see, cosine C. Cosine C gonna be cosine adjacent of C, okay, is 6. So it's a 6 over hypotenuse 10. So it's 6 over 10. Okay. After that, let's calculate the first required. It's a sine A. Sine A is 6 over 10. So it's 6 over 10. Multiply. Cosine C is 6 over 10 also, so it's 6 over 10. 6 over 10 times 6 over 10 is 36 over 100, gonna be 0.36. Second required. Second required, sine power 2a plus cosine power 2a. Sine A is 6 over 10, so it's 6 over 10 power 2 plus cosine power 2a. Cosine power 2a, it's cosine A, it's 8 over 10. So it's 8 over 10 power 2. Gonna be 36 over 100 plus 64 over 100. Okay, gonna be 100 over 100. It's gonna be equals 1. Okay, see you in the other videos.